You're welcome. This is your revision show on your Joy Learning channel. It's a pleasure coming your way tonight with another fantastic experience. Well, my name is Danso, and tonight, in wishing all my final year students the best as you prepare for the exams, let's together, for one more time, go through that topic that you can be sure will show up. Tonight, we'll be dealing with bearings and vectors. Bearings and vectors. You're welcome to the show. This show is interactive, and from very early on in the show, we would like to hear from you. We'll be solving some questions together, and I would love to hear from you. Right. Tonight, we'll be revising that topic, bearings and vectors. And like I mentioned, my name is Danso, and it's a privilege coming your way. Now, so let's go into a few definitions, a few things we'll touch here and there. Just as a caveat, let me quickly say here that it will be impracticable to solve all the problems that there could be in bearings and vectors. But you can be sure of one thing: we will cover enough ground for you to walk into that exam room and deliver at your very best. If you are not a final year student, maybe you are in your first year or second year, this would be a great opportunity for you to learn or maybe even revise it. After all, it's a revision show. Well, you're welcome. Let's do a few definitions here and there. Bearings and vectors. What do we intend to achieve today? A few very specific things. Number one, I'm hoping, and that's where my first drill will come from, that you will be able to read and interpret bearings. What are bearings? We'll talk about that. Well, secondly, I'm hopeful that you will be able to correctly represent vectors in different notations. There are a few notations. I hope you get to learn them and use them well. And I hope you'll be able to perform basic arithmetic procedures on vectors like addition, subtraction, etc. And there are laws for them, so I'll get you to use those laws. Finally, we should be able to use our knowledge of bearings and vectors to resolve problems dealing with geometrical shapes and distance bearing problems. I hope we'll make this together. For me, it's fun. I hope it becomes fun for you too. So let's get going. A few definitions to start off. What are bearings? A bearing is an angle in degrees measured clockwise from the north. In general, that's a bearing. It's an angle or angles measured from the north in a clockwise manner, and the value or the unit is always in degrees. Now, there are different types of bearings. Two of them we would consider tonight as we revise will be the two. The first will be our compass bearing. The compass bearing. Now, when we mention north, it should interest you because, well, the only time you hear north is when you're talking geography, right? Yeah, north. So the north is our reference point, and we measure clockwise. For the compass, it has 4 ordinals. So you have the measurement using the cardinals of a compass. And usually we would write it in this way. Maybe north 52 degrees east, south 60 degrees west. What do those things mean? Never mind. Let's take it gently, but these are some of the ways it will be presented to you. When it is presented in this way, no need to fret. We can deal with it. Now, what is the other way or the other types of bearings apart from the compass bearing? Well, we have the 3-figure bearing. The 3-figure bearing. Well, why is it so called? Why is it called 3-figure bearing? Well, it's because, again, it is measured from the north, quite all right, but the values are always left in 3 figures or 3 digits. So, for example, you could have 002 degrees or 112 degrees. You notice that 002 degrees, ordinarily we could have said 2 degrees, but we prefer to leave it in 3 digits as a standard. At this point, let me encourage you to get yourself a notebook, a pen, or a pencil, and for this particular topic, if you got yourself a calculator and mathematical set, or at least a compass and a protractor, and maybe a ruler, it will be great. So, let's look at the compass bearing a little closely. So, we have that. Your compass should always have the north, south, east, and west. North, south, east, and west. Get used to this because sometimes, just to test your knowledge of compass bearing, the problem will not be given you in 3-figure bearing, which is something most of us are used to. It will usually come or sometimes come as the compass bearing. So that is north, east, west, south. Your south could be where your feet are, your north is where your head is, and consider your right hand as your west and your left hand as your east. Well, if I assume that you're using a number line. Okay, now, but these are the fundamental ordinals, but there are others. So between north and east, there could be something else. Between north and west, there could be something else. Now, what this first does is to divide a circle into 4 parts. So these 4 ordinals have divided the circle into 4 parts, 90 degrees on every side. But we could have something more. So you could have northeast and northwest and southeast and southwest. With the addition of this, it has been divided further into 8 parts. Each part now 45 degrees. So northeast, southeast, southwest. So if we had north 52 degrees east, it will be somewhere between the north and the east, measured from the north. Remember, it's always measured from the north. Always from the north. I can't repeat this enough. Always from the north. Now, so we have our circle now divided. Now, you don't see a circle, but there is, because they're all angles that meet at a point. So we have 8 sections now, if you like, 8 sectors. But we could divide it even further so that we have something like that. So you could have north-northeast, or west-northwest, or west-southwest, or south-southwest. Okay, so you notice I said north-northwest. North-northwest will be between north and northwest. So as you can see on your screen, if I were to go 1 step backwards, we have northwest. If I introduce the new ordinals, we have 16, so that each sector will be 22.5 degrees. So between northwest and north will be north-northwest. Between southeast and east will be east-southeast. Why so? Because it is closer to east than it is to south. However, the division between south and southwest will be south-southeast, because it is closer to south than to the east. I hope you are getting it. All right, so that is compass bearing. So if you're given north 52 degrees east, you'll be measuring from the north 52 degrees until you get eastward. If it is 52 degrees north, 52 degrees west, then you'll be going to the left, backwards. I hope you're getting it, and you should be able to convert. Now, as soon as you're able to convert and you notice the location it is, then the next type of bearing will hold on. It will be the 3-figure bearing. So now, let's look at this, and I need you to pay attention here. After this, you will have the opportunity to call in while I give you a problem to solve. So now let's test this. So in a three-figure bearing, we have our north-south, but we're measuring from the north. So the vertical is how we measure when we're dealing with bearings. All right, so if I have a point A from the origin O, and I have that 20 degrees there, what will be the bearing? Now, please watch this carefully. My drills will be based on this. So after this, you'll be free to call in, and when you call in, I'll be asking you to tell me what the bearing of a particular point is from the north. Now, although it is 20, you would notice that 20 degrees is to the horizontal, more like to the east-west. So that is not the bearing. It cannot be 020 degrees. There is a temptation to say, oh, it's 020 degrees because you can see the 20. No. The bearing really is from the north. And since the north and east, that's the vertical y-axis and the positive x-axis, form 90 degrees, the angle between north and A is what you're looking for. Not between A and the x-axis. No. That would be 020, and that would be wrong. So what you're really looking for is from the north until you get to the line A. All of that from the north to the x-axis is 90 degrees. So take 20 from 90, you're left with 70. So the bearing of A from the north is 070 degrees. I hope you got that. Yes. So always measure from the north. There's a temptation to pick the value that you see. Please don't fall for that temptation. I believe you get it right. Okay, so let's try another one. So I have 30 degrees there between a point B, a line B if you like, and the south. What will be the bearing of B from, say, the north, or the bearing of B? What would it be? Again, remember, we measure from the north. If we measure from the north all the way to the south, that would be 180 degrees, 90 plus 90. But 30 has been chopped off. So from north until we get to that purple line, B, what would it be? It would be 180 minus 30. So our bearing there in three figures will be 150 degrees. Dakun Samuel, good evening.
Good evening, sir.
Yes, Dakun Samuel, I'm about to give you one problem, but tell me, where are you calling from?
I'm calling from Konango in Ashanti region.
Fantastic. What class are you, if I may ask? Oh no, I lost Samuel. Samuel, so sorry about that. I was going to give Samuel a problem to solve. And unfortunately, his lines did not help him. Call again, Samuel. I'll be pleased to give you a problem to solve. Okay, so let's go back a step, just so that we all can follow. So we have our first bearing, A, and we're trying to find what's the bearing. From the north, we are reading from the north. The temptation is to pick the value you see. Please don't fall for it. So usually in your exams, you have option A, 020 degrees. Option B, 050 degrees. Option C, 070 degrees. Option D, 090 degrees. The temptation is to pick option A because you saw 20. All right, that would be wrong. You measure from the north. Remember, between the north and the east is 90 degrees. Between east and south, 90 degrees. Between south and west, 90 degrees. Between west and north, 90 degrees. So what is left after the 20? Oh. Nana Markon, you are on the line. Good evening.
Good evening.
Yes, Nana Markon, please, where are you calling from?
I'm from Dunkwa, Onofe.
Fantastic. So I am going to give you a problem to solve. Is that okay?
Thank you, sir.
All right. So, by the way, the angle on the board, the bearing, tell me the bearing for B, what would it be?
It will be 60 degrees.
Oh no, remember we are measuring from the north. So look at it again, from the north. What would it be? Hello, Nanadakon.
Hello.
Okay, so we're measuring from the north. It's not just what is left. It is all the way from the north. So from the north to the east, what do you have? What's the angle between the north and the east? What angle would you have? Oh, I lost Nanadakon again. Too bad. Right, I'll linger a bit. Let's see who gets this one right. Actually, I gave the answer away a while ago, but if you call in, I would want to know how you arrived at it. That would be great to know. Nanadakon was close, but he was not quite there. Always remember, we're measuring from the north. From the north. From the north until you get to the line of the bearing. So from the north until we get to A was 70, because 70 plus the 20 gives us 90. All right, so if we measure from the north to east, we'll get 90. Something is missing before the 30. Nanadakon said it's 60. If we added the 60 to the 90, we'll get 150. That is one way of looking at it. Another way of looking at it. Hello.
Hello.
Hello, Leila.
Yes.
Good evening.
Evening.
Please, why are you calling us from, Leila?
I'm calling from Upper East Region.
What part of the Upper East region?
Boku.
Boku. Fantastic. So, Leila, have you followed so far?
Yes.
Okay, so Leila, I'm going to give you another bearing C, and please try telling me what you have. Is that okay?
Okay.
By the way, what class are you? You are in form what? What form are you, Leila? Hello, Leila?
Yes.
What class are you?
Form 2.
Oh, great. So, Leila, now, this is your problem. Tell me, what is the bearing of C? What's the bearing of C, Leila?
Sir, please, I'm coming.
All right, that's great. I'll be waiting.
Okay. Plus 9. Sir, it's 120.
Not quite. Remember, from the north. From the north, Leila. Start measuring from the north. You are in a northern region, so I expect you to get it right. You're measuring from your place.
Okay.
Okay, so try again, Leila. Okay, so Leila, let's go together. From the north to the east, how many degrees do we have there?
90.
Okay, from east to south, how many?
90.
So if you add them, what do you have?
That's 180.
Good. There is a value missing before 50. What value would that be?
The value missing with before 50.
Between C and the south. What's the missing value?
90.
No, between C and the south.
There's no value there.
Okay, so what value do you think should be there?
It should be 130.
Okay, so Leila, let me guide you again. And every other person watching, let's do it together. So I'll go a step backwards. So Leila, are you following?
Yes.
Okay, so from the north to A, there is an angle, but it is not written, right?
Yes.
Good. But we know that between the north and the east must be 90 degrees.
Yes.
I call the east your positive x-axis. That would be 90. So
yes.
Since it is not written, and from the A to the east is 20, then what is missing has to be 70. Is that not so?
Yes.
Good. So every time, remember, you are measuring from the north. From the north. From the north until you get to the line of the bearing.
Okay.
So we have 70 there. But when we write it, we don't write 70 degrees. We write 070. They must always be in 3 digits. Now, the second one. Look at B. If we start from the north until we get to the purple line B, there will be an angle. We know 70, we know 20, but the next angle is not given. But we know that the straight line north-south must give us 180, not so?
Yes.
Good. So if we take 30 from 180, what do we have?
150.
Great, and that's our bearing. Now, so Leila, try your own question now. So what would this one be? C. What would it be?
It will be 130.
How did you get the 130?
Moving from south to west is 90.
Yes.
And then there is 50 degree here.
Yes.
You take away 50 from 90.
Yes.
You get remaining 30. You add a 30.
No. Leila, pause. If you take 50 from 90, you get what? If you take 50 from 90, what do you get?
40.
Great. So what did you do with the 40?
You add the 40 to 180.
And what do you get?
You get 120.
No. Add it again. Try. Leila, I want you to get this. Add 80 to add 40 to 180. What do you get?
0120.
No. 180 plus 40. What do you get, Leila?
No, 180 plus
220.
Fantastic. And Leila gets it correct now. So Leila, you are right. It was 220 degrees. So that's the bearing of C from the north. Leila, congratulations, you got it right. Congratulations. All right, so your addition was almost playing some tricks on you, right? Thanks for calling, Leila. Thank you. Now, there is a last one on this section. There will be 4 more. So this is not the end. Let's try one more. So somebody tell me what the bearing of D is. Hello? Hello?
Hello.
Yes, who do I have on the line?
My name is Shaibu Suleiman.
Shaibu, good evening.
Fine evening, sir.
Please, where are you calling from, Shaibu?
I'm calling from Accra.
What part of Accra?
Mamowi, precisely.
Oh, great. So, Shaibu, tell me, what is the bearing of D?
The bearing of D.
Yep.
Oh, okay. We have measuring from north.
Yes, from the north.
From north to south, we have 180.
Great.
Then from south, from the same north to the D, the line X. So we have 180 plus another 180. So the whole circle is 360.
That's great.
That is, we have 360. So 360, I'm coming. 360 plus 220 minus 60. Let me do my calculation.
Okay, Shaibu, that's great. Shaibu, take it easy. Take it easy. You will get it.
All right.
Take it easy.
We have 20 degrees plus another 30. 30 plus 50. I'm coming later. Seconds. Let me do the calculation.
All right. I'm patient for you, Shaibu. You will get it. Believe me, you'll get it.
30. This 50, 100 plus.
Okay. So, Shaibu, can I give you a clue?
Yes. I'm adding the, if I have 20 plus 30, that gives me 50. Plus another 50, that's 100. Plus 160, this 160 minus 360.
Shaibu.
Yes, please.
Okay, so this is a trick. Look at it. From the north to the east, 90 degrees, right?
Yes.
From the east to south, how many degrees?
East to south is 180.
No, east to south. What do you have?
East to
south.
50.
No. Just east to south. 90. Great. South to west, how many degrees?
90.
And west to north is what?
90.
So it's 360, right?
Yes, 360.
So every time you are trying to find out, just remember 90, 180, 270, and 360.
Yes, that's what
So from north to south is 180. That is covered, right?
Yes.
And you're moving all the way to the west.
Yes.
That's 270.
Yes.
So before you get to D, there is a missing angle. What is that angle? It is the angle before 60.
Yes, please.
What is that angle?
So that means 90 minus 1.
No, 90 minus.
90 minus 60.
Good. So what do you have?
90 minus 60, we have 40.
No.
No, not 40. 90 minus.
No, relax, Shai. Relax. Take it easy.
I have 30.
Good. So what do you do with the 30?
Yes, please.
So what do you do with the 30?
I've added 30 to the 90.
No, don't add it to 90.
Sorry, to the, what's the name? The 60.
No, you can't. If you add it to 60, you get 90 back. Okay, so the trick is we have covered 270 already. We just need something more before we get to D, and that is the 30. So what do you do to the 70, to the 30?
Hello, sir.
Yes, hello.
Hello, sir. Come again.
Okay, so north to east, 90. North to south, 180. North to west, 270, right?
Yeah.
So what is left? What's that empty space? 30, right?
Yes.
So what do you do to the 30?
You subtract.
No, you don't subtract. Just add it.
Okay.
You add it to 270, and what do you have?
Oh, okay.
Because we are moving from the north. That's the direction. We're moving clockwise.
Okay.
So when you add it, what do you have?
You have 300.
300, and you're right, Shaibu. You are right. All right, so there is a trick. The trick is always look at the complete one, and you can take, so for example, the full cycle is 360, right?
Yes, please.
And 60 is between the bearing and the north. So just take 60 from 360. You get your 300 very quickly.
Okay.
All right. Thank you, Shaibu, for calling from Mamubi. Thank you for getting it right also. All right.
Thank
So viewers, we're going to do a few more drills. 4 more on this. 4 more drills on this. So let's try. All right. Who do I have on the line? Oh, I seem to have lost that caller. Anyway, no problem. We will do a few more drills in the course of the show, and it will be great to hear from you. Let's talk about a few more concepts. Now we've been able to determine a bearing, and we said all bearings are measured from the north in the clockwise direction. You could leave them in their compass form, north, east, southwest, or you could write them in their 3-figure form, 007, 070, 120, etc., etc. All right, and remember, you're always measuring from the north. So it includes everything until you get to the bearing itself. All right, so let's talk about back and reverse bearings. We'll do some more of these drills. Back and reverse bearings. What do we mean by back or reverse bearings? I will illustrate with a diagram. So suppose you are traveling. Nanayao, good evening. Hello, Nanayao.
Good evening, sir.
Yes, you came late to the party, but what do you have to say, Nanayao?
I wanted to answer the question.
No problem, Nanayao. There will be a few more questions for you to deal with. So please keep following the show. Is that okay?
Okay, sir.
Please, why are you calling from Nanayao?
Kumasi.
Okay, great guy. So just stick with us. Is that okay?
Okay.
All right. So let's talk about back and reverse bearing. So now, if you're on a dual carriage road, what that will mean is that some cars are moving, say, downhill, but other cars are moving uphill. Now, if you have 2 locations, say 2 towns, towns A and B, on that stretch of road, the person moving from A to B, although he may be covering the same distance as the lady moving from B to A, their directions are different. And that's the whole idea of bearings and vectors. And we'll talk about that in a very short while. So, the bearing of A from B is not the same as B from A. Although the distances will be the same, the directions will differ. So One of them, A is on top, B is down, and I'm assuming that the road is on a hilly place, maybe Kwewu or somewhere in the Akwapim Ridge. So A to B will mean he's moving downwards, and B to A will mean she's climbing upwards. Now, that's the concept of bearings. A back bearing or a reverse bearing is the opposite of the initial one spoken of. Look at this diagram. We have, say, a town A and a town B. The bearing of town B, and please note the use of the words from and of. So the bearing of town B from A is 060 degrees. Remember, we are always measuring from the north. So look at the direction of the arrow in that diagram. You will notice it traveled from the north until it hit the line AB. All right, so the bearing is 060 degrees. That is the original bearing of town B from A. If I want to find the bearing of town A from B, now it means I'll be starting at B. You notice that now. You notice because I have to start from the north, I go all the way until I hit that line and I get 240 degrees. Why do I know it's 240? It's because the 60 degrees here will be alternating here as well, because the lines east to west here will be parallel to the east to west down there. So the line AB becomes what in geometry we will call the transversal. When there is a transversal, you will have alternating angles, consecutively interior angles, adjacent angles, vertically opposite angles, corresponding angles, etc. So the 60 degrees here will be equal to, there will be another 60 degrees there. And since all of this will be 180 degrees, if we add 180 to 60, it becomes 240 degrees. I guess you get that. So the bearing of town B from A, 060. The bearing of town A from B, 240 degrees. In general, we say that if the angle of the first bearing is less than 180 degrees, its back bearing will be that angle plus 180 degrees. So if the bearing is 070 degrees of B from A, then the bearing of A from B will be 70 degrees plus 180 degrees, which will be 250 degrees. If, on the other hand, the original bearing is greater than 180 degrees, then its back or reverse bearing will be that angle minus 180 degrees. So, for example, if the original bearing of town A from B is 240 degrees, then the bearing of the bearing of B from A will be 240 minus 180 degrees. I hope this is clear enough. Great. So let's do our drills again. And I hope Nanayao and friends will call. I'm going back to the original problem. Let's try it one more time. Let's see how this works. So I have P, and I need you to call in now. I have 4 points, P, Q, R, and S. And I want to know what the bearings of P, Q, R, and S are. I'll be waiting to hear from you. So let me have the bearing of P, the bearing of Q, the bearing of R, the bearing of S from O North. Hello, Nanayao.
Hello, sir.
I love your determination, Nanayao.
Thank you, sir.
Nanayao, what school are you, by the way?
Kumasi High.
Oh, fantastic. What class are you?
Form 1.
Yay, you're a great guy. Are you a science student?
Yes, sir.
Oh, great. What would you like to become? Yeah, not too sure. No problem. So tell me the bearing of P.
Okay, so the bearing of P is 90 minus minus 41.
All right.
49 degrees.
Okay, so
049 degrees.
fantastic. I'm clapping for you here.
Thank you, sir.
And Nanaya, I like the spirit. You just behave like those competitors on the National Science and Maths Quiz platform. You called before you even knew the answer. That's great. So you are right. Nanaya is right. So the bearing is 049 degrees. He was quick to correct himself. It must be 3 digits all the time. All right, so Nanaya deals with the first of 4. Who deals with Q and R and S? By the way, if you call, I don't want for R if Q has not been answered. So we must go in that order. So I want to hear from you. What is the bearing of Q from the north? Or what's the bearing of Q? OQ. The bearing of line OQ. What is the bearing? Hello.
Hello, sir.
Yes, you are from Teshi. What is your name?
Hey, please, I'm Joe.
You are Joel.
Yes, sir.
All right, Joel, you're welcome to the show.
Okay, sir.
Joel, what school do you attend?
Sir, Kumasi Anglican.
Wow, Kumasi guys, you guys are really powerful. Okay, so Joel, tell me, what is the bearing of the line OQ? Hello, Joel.
Hello, sir.
Are you calculating it?
Sir, 126.
126. Joel, check that again. Check that again.
Sir, 156.
Joel, careful, careful. Take it easy, Joel.
Okay, sir. Sir, 136.
All right, now Joel gets it. Joel, how did you get 136? You are right, by the way, but how did you get it?
Sir, like from N to Q.
Yes.
It's 180.
Yes.
So I
No, you mean from the north to where?
Sorry, from the north to the south.
Yes, 180.
Yes, sir. So I subtracted 44 minus 180.
Simple as that. Just simple as that. You are right. So we have 136 degrees as the bearing of the line OQ or the point Q from the north. All right. Thanks, Joel. Nanaya gets the first. Joel gets the second. Who gets the third? Hello.
Hello.
Yes. Who do I have on the line?
Sir, Edward.
Edward, you're welcome. Where are you calling us from?
Apromasi.
Okay. So what's the name of your school? Are you in school?
No, sir. I'm a JHS guy.
Oh, that's great. That's great. So tell me, what's the name of your junior high school?
Domia Brahim JHS.
Oh, I love you. So I've come to you tonight. Okay, so Joe, what's your name? Edward, right?
Yes, sir.
So Edward, tell me, what's the bearing of R?
Sir, R is 23. 023 degrees.
Okay, so Edward, remember we always measure from the north.
Yes, sir.
So if you measure from the north, what would that give you?
223.
223
degrees.
No, check it again. You are almost there. It hurts to get it wrong. Check it. You're almost there.
Sir, 203 degrees.
Fantastic. 203. You get it.
Yes, sir.
Yeah, that's cool. So, Edward, there's a simpler way. Remember, from north all the way to the west, that is the negative x-axis, it will be 270.
Okay.
Just
sir.
take 67 from 270 and you get your 203.
Yes, sir.
Thank you very much. Thanks for calling.
Okay, sir.
All right. Who is going to give us our last answer for S? Hello?
Yes, sir.
Good evening.
Good evening, sir.
Who do I have on the line?
This is Fred calling from.
Yes, Fred, calling from.
Who?
All right. How is Ho today?
Yeah,
How is Ho today?
everything is good.
Great.
Yeah, fine, yeah.
What is the name of your high school?
I'm schooling at Rara.
Rara. All right. So, what class are you?
I'm in Form 1.
Oh, I love you, Form 1 students. You're making me excited. So tell me, what's the bearing of S?
So S is the whole circle is 360.
Yeah.
So 360 minus 80.
Okay.
360 minus 80.
Yeah.
That's is 280.
It's what? Say it again.
280 degrees.
Can the whole of Ghana and West Africa clap for this gentleman from Rara? That's a great one. You are right. 280 degrees. Thank you so very much. Your name is Godfred, right? Thank you so much for calling. You are right. And so I believe that with this... Hello? Hello?
Hello.
Who do I have on the line? Good evening.
Good evening.
Who do I have on the line?
This is Felix.
This is?
Felix.
Felix. Okay, Felix, you wanted to say something?
Yes.
Yes, Felix, let me hear you.
Oh, like I wanted to answer the question.
Oh, so he came ahead of you.
Yes.
But you get the idea, don't you? Where are you calling us from?
Oh, I'm calling from Begro.
Begro. Great.
Yes.
What class are you, Felix?
SHS2.
SHS2.
Yes.
What course do you offer in school? Or what course were you offered? Say again.
General Arts.
General Arts. Great.
Yes.
I hope you're getting it right at this point.
Yes, madam.
I'm really excited. Thank you very much, callers. So we'll do a few more things, and I'll open the phone lines again for us to cover a few more grounds. So now that we've dealt with bearings, let's deal with vectors. All right, what is a vector? A vector is any quantity that has both magnitude and direction. It has magnitude and direction. Why is that important? Why do we have to study quantities that have both magnitude and direction? It is because I want you to think about it this way. Wherever you are now, if you said to me, or you called in and you said, Danso or Sedanso, whichever one you prefer, I am 4 meters from my friend. If you said that, you would not be wrong, but you will be giving me an incomplete information. Why? Because 4 meters, your friend being 4 meters from you, could be 4 meters to your left, 4 meters to your right, or 4 meters in front of you, or 4 meters behind you, or anywhere in between any of these. So if your friend is 4 meters from you and you wanted to show me exactly where he was, you needed to add a direction. And that is why we dealt with the bearings. So there must be both magnitude and direction. The direction makes the information more complete. All right, so for example, we know that your mass is the quantity of matter that you contain. Often when you step on the scales, you will say, I weigh 70 kilograms. Well, strictly speaking, that's your mass, not your weight. Your weight is your mass multiplied by acceleration due to gravity at your location. It varies between 9.8 meters per second square and 10 meters per second square. So weight is a vector, mass is a scalar. 4 meters is a scalar. 4 meters due east or due west, or 4 meters north 60 degrees east is displacement. It is more specific. So displacement is a vector quantity. Distance is a scalar. Other examples of vectors or vector quantities would include stuff like acceleration, force, velocity. All right. Each of these deals with direction. They're direction specific. All right, so a vector must have magnitude and direction. And there are many ways of symbolically denoting them. So I'll show you a few of them as we get along. So let's represent it. Generally, as a diagram would represent vectors by arrows with arrowheads. Arrows with arrowheads. In other words, if you are going to denote a vector and you do not have an arrow, you are not defining a vector in the strict sense, unless it is something else I'll talk about shortly. So there must be an arrow with an arrowhead. And the length of the arrow determines how long or how the magnitude of the vector. So the bigger the vector quantity, so let's say the greater the force, the longer the arrow should be. So if I have two arrows, like the other one there, so I have one arrow ST, or a vector ST with the arrowhead, and another vector UY. Well, ST, if they are of the same quantities, if they're all measuring, say, force or say acceleration, then the vector ST must be greater than the vector UY. I hope you get that idea. And something to quickly note is that the first alphabet we use is the starting point, and the last alphabet is the end point. So begins from S, ends at T. Begins at U, ends at Y. So it tells the direction. So it's like traveling. You move from a town, Sotuom, and you move to Teshi. If you were moving from Teshi to Sotuom, it would have been TS. I hope you get the idea now. So the alphabets there show the beginning and end points. I hope you get that. Because they'll become useful, as you'd realize, going downhill is not the same thing as coming uphill. The distances may be the same, but they're not the same, especially if you were walking. Going downhill is easy. You could just glide all your way down. But coming up is quite challenging. So vectors are important. Types of vectors. There are lots of vectors, many of them. We'll consider a few of them just because we are revising. So we have the zero vector and the unit vector. It's called zero vector because its magnitude is 0. A zero vector has a magnitude 0. Its direction is really not very specific. Because it is 0, it's difficult telling where it is. The 0 is like your 0 point on your Cartesian or on your number line. It really doesn't have a direction. It's just a neutral point. So a zero vector is a vector whose magnitude is 0. A unit vector, on the other hand, is a vector whose magnitude is 1. It's 1. Its magnitude is 1. And it's important in math when we deal with zeros and ones, because zeros and ones are what we call our identities. They give identities to things. So for example, if you multiplied any number on earth by 1, you should have that number back. So 1 is called the multiplicative identity. If you added 0 to any number, you should have the number back. So the number 0 is called the additive identity. So our zero vector and our unit vector help us to determine identities of the vector or vectors. All right, there are a few more. The position vector. This is the vector where you do not have to draw an arrow because it is denoted differently, and I'll show you. The position vector just helps to locate places or locations. It helps us to put a name to a thing in very specific terms. Usually we denote it with small letters, and we'll talk about that shortly. Then the negative vector is the opposite of the original one. So if ST is the vector, its opposite will be TS. Just the reverse of it. I'll show you a few diagrams and let's go together. By the way, the negative vector would always have, it will be opposite in direction, and it doesn't have to be equal. Okay? It may not be equal. All right. So let's talk about equal vectors. A vector is equal, or two vectors are equal if they have the same magnitude, essentially. They may have different directions, but their magnitudes have to be equal. So equal vectors may, like the towns A and B, Ashaiman to Brekusu may be the same distance, and they have to be the same distance. So anybody traveling from Ashaiman to Brekusu should ordinarily, if there was no traffic holdup, should have the same distance covered in the same time as the person traveling from Brekusu to Ashaiman, assuming they all are traveling at the same speed. All right. Now, so equal vectors have the same magnitude, but their directions are different. They may not be different. In fact, they could be the same, but they must have the same magnitude. All right. Collinear vectors. The word collinear simply means they are on the same line. Vectors that slide or glide or are on the same line are collinear vectors. They are important especially for the elective math student because you'll be investigating the properties of, say, forces acting along a certain line. In your integrated science, you have dealt with work, and you say work is force multiplied by the distance perpendicular to the application of the force. So F multiplied by D gives you collinear forces. All right. Then coplanar vectors. Vectors are coplanar if they are on the same plane. What is a plane? You say XY plane. It simply means an infinitely stretching flat surface. So the ground is a plane because it stretches infinitely. Your eyes cannot get to the end of the ground. If your eyes can get to the end, it means that you are bounded by a wall or something. So coplanar vectors are vectors that are in the same plane. Either they are all in the X plane or all in the Y plane, etc. Then we have co-initial vectors. In other words, they come from the same source. Initial, they're initiated or they come from the same source. So if two or more vectors come from the same source, we call them co-initial vectors. All right. Look at the diagram on your screen. We have three sets of vectors. Vector OL, OM, ON, one set. Vector AB and vector CD, another set. And we have vectors XY and YX, another set. All right. Let's look at this carefully. You would notice that vector OL, OM, ON, this is how they emerged. So they all meet at a point, so they are co-initial vectors. They emerge from the same point. So you notice they're pointing outward. So they are co-initial vectors. All right. We have vectors AB and CD. You notice, first of all, they are in the same direction. They're all pointing upwards, northeast. They're all pointing northeast. All right. Now, but there's something more about them. If you watch carefully, you would observe that they have the same length. So they are equal and parallel vectors. They are equal and parallel vectors. The third set of vectors are opposite. So we have XY that way, and then we have YX in the opposite direction. So you notice that in the second vector, we put position vector negative P, and that's the position vector I was talking about, negative P. And it starts from Y to X, whereas the first one began from X to Y, and it was positive P. So these are some vectors, but all of these vectors, especially A, B, C, D, X, Y, and Y, X, if you observe carefully, they could all slide on the line L, purple there. So they are all collinear. They're on the same line. They are parallel to each other. Collinear vectors are parallel to each other. They could be moved, transposed one onto the other without affecting their direction or even their magnitudes. All right. So let's talk about the position vector, and we will do a few things. The position vector, we talked about it in our definition. The position vector, consider our axis OX, OY. If I have a vector emerging from point O, this way, so vector OA, and I have another vector emerging from the same O, what would it be called? Yes, co-initial vectors. Emerging from O. By the way, OA has been given a name called A, small letter A. That is the position vector for vector OA. If another one emerges, OB, it will have the name, say, B. What would happen if we attempted to add vector OA to OB? Well, there's a simple principle. The simple principle is that the arrows must follow each other. And if you watch carefully, OA is not following OB because they are co-initial. So what do? We have to join A to B. When we join them, we will have the arrow moving in that direction. So we say that vector OA plus vector AB will be equal to vector OB. So you notice the arrows are following, so that it's almost like a complete cycle. OA, AB, when you join it, you have OB. Now, this raises an important concept called the resultant of a vector. We will deal with it in better details subsequently.